All right, so now this is the basic principle of rational expressions. So the following property can be used to simplify rational expressions where P, Q, and R are polynomials. So if we have P times R over Q times R, again, these are polynomials, we can say, okay, well, that's just P over Q, and then Q and R are non-zero. Because if we have Q is zero, then it's going to be nothing. But these, again, are all polynomials, okay? So in this case, we are supposed to simplify the expression. All right, so without it actually moving down to do this, what we can do is we can say, okay, well, what do we have here? Well, that 4 will go in here once, 4 will go in here 4 times. Now, one of these y's will cancel one of those y's, and so we just have 1 left here. So it looks like we end up with 4 over y for our solution for that first one. Now, what about the next one? And I'm going to go ahead and show their solution in a little bit, but this is what we're going to have here. Well, if we pull out a 3, we're going to have x plus 4. Here, if I pull out a 4, I'll have x plus 4. Well, guess what? X plus 4 cancels x plus 4, and I get 3/4. So that one is just going to be 3/4. Now here we have to think about this. We have to remember that when we factor, that's going to be x plus 5, x minus 5. This one's going to be what? 2x and x. And let's see if we have a 5 and a 3, and it's a minus 5 and a plus 3, then that will give us a 3 minus 10, so it's going to be minus 7. So now we have that, and now we see that x minus 5 cancels x minus 5, and we just get x plus 5 over 2x plus 3. Now, let's do this written out by hand. And so, if they say, okay, well, we can pull out a 4y and we get 4 over y. Here, they're saying, well, now we factor kind of like I did here, and then we can cancel those and we get 3/4. And here, we're going to factor like I did, and we're going to cancel, and we end up with the same thing. So that's kind of the way we're going to do this. Now this one is a little bit different. I went ahead and did it like this, but what we did here is we factored out the GCF, and then we have the 4 over y left over. All right, what about here? Well, let's do the same thing we did before. Now here, I'm going to take out a -1, and then I have y plus 7. That way, I see that this is probably going to be only positives. So then if I pull out a 2, I'll have a y plus 7. Now, cancel the y plus 7s, I get a -1/2. Now here, we can rewrite this and we say, okay, well, that's a minus. Now let's pull out a -1 and we have, now let's put this here and we're going to put this here. So that's going to be x minus 8 over, and then we have, now we have x minus 8. Now here we have a minus, so that's going to give us a plus, and that happens, we cancel everything out. And we can see that when we do this one, we get a -1/2. And when we do this one, we get 1. And that's kind of what we show here too. Okay, so just different ways to kind of show you different ways to look at these examples. All right, so here, more of a real world application, more or less. So suppose n balls are numbered 1 to n, are placed in a container, and 2 balls have the winning number. What is the probability of drawing the winning ball at random? Calculate this probability for n equals 100, 1,000, and 10,000. And then what happens to the probability of drawing the winning number or winning ball as the number of balls increases? All right, so first off, there are 2 chances of winning the winning ball. So that means we have 2 out of n total things. Now we're supposed to calculate the probability for 100, 1,000, and 10,000. So guess what? We're going to divide those by 100, 1,000, and 10,000. So we reduce that to 1 over 50. Reduce this to 1 over 500, and we reduce this to 1 over 5,000. Okay, so that's the probability to win. Now, what happens to the probability of drawing the winning ball as the number of ball increases? Well, here, it's not too bad, 1 out of 50, but 1 out of 5,000, that's not so good. So it's a lot less, it's a lot less probable we're going to win. So basically, your probability decreases. All right, so that's all I have for this section. So hopefully that will help, and I'll come back with exercises later.